Hi everybody, here is your kind of first lesson on probability, and it's kind of still a review. I gave you that review sheet on Friday just to start a little warm up of 7th grade. 7th grade was the last time you guys saw probability. So we're just going to talk today, again, very basic, just talking about how we can express probability and their answers. So as you guys know, probability there's a lot of notes today. It's a branch of mathematics that is focused on explaining behavior of random events. It's the idea of a chance or randomness. In probability, that is often something that is a bit challenging to think about. So we do want to apply these to single event outcomes and help making sense. So you guys can read this. I don't need to read this to you. So some definitions. You're going to talk about a set is a collection of numbers or other objects. The numbers or items in a set are called the elements. An experiment is some process that occurs with well-defined outcomes. Sample space, which S of an experiment is the set of all possible outcomes. We're going to see sample space a lot today. And an event is one or more outcomes in a sample space, a subset of the sample space. So another few little just key important things that you guys need to know about are the probability that an event A would happen would be the number of times that event A happens over the total number of times of outcomes in that sample space. Understand in that next little event that for event A, the probability that event A is going to happen is any number in between 0 and 1. It could be 0 and it could be 1. It's either never going to happen or it could happen for certain. And then there's the complement rule. So the probability of A not happening is 1 minus the probability of A happening. So we're going to see that a lot today as well. So if you just look at our first example, it's a spinner, and this spinner is set into 5 equal sectors, numbers 1 through 5. So first thing they want you to do is just write the sample space, S, so they tell you S, in set notation. This is important, set notation for the experiment described. So they're telling you to make it S equals, and here's your set notation. So what are your possible outcomes? It's either 1, 2, 3, 4, or 5. So there is your possible sample space for letter A. It says in part B, let E be the event that an even is spun, okay? And write E in set notation. So we're letting E equal an even number. So our even numbers here would be just 2 and 4. Okay, and your next one is just let P be the event that a prime number is spun, and write P as set notation. So what is prime? Prime is going to be 2, 3, and 5. Remember, 1 is neither prime nor composite. So in this example, you're going to use those set notation to answer these next few questions. So what's the probability of E that you get an even? That would be 2, because there's 2 evens, 2 and 4, out of your 5 possible outcomes. E, what is the probability that you spin a prime? Well, there's 3 prime numbers, so 3 out of 5. Okay, good question. What is the probability that you're not going to spin an even? So just think about this. This is literally, okay, not even. It's 1 minus even 2/5. So think of 1 as 5/5 minus 2/5, and not even is just 3/5. How else can you think of that? Well, anything that's not even is odd. So 1, 3, and 5. Those 3 numbers out of the 5. But understand again what not means. It's just the opposite of whatever you have. So like the probability of even, not even is 1 minus even. What's the probability of spinning here? 6. Never. 0. Okay. So let's take a look at your next one. There are 2 different types of probabilities. You guys are going to be seeing theoretical and empirical. Very different and important for you guys to understand the difference. Theoretical is what we expect to happen based on a sample space, and Empirical is what actually happens in an experiment or an observation. So in that last example, that previous example, based on the sample space, that was theoretical. Okay, so they're going to say to you, like, oh, in this example, in this experiment, then you're going to be talking empirical. But if not, it's just what we expect to happen, which would be theoretical. So, like, even in this next example, a fair coin is flipped 3 times, and the result is recorded each time. Write a sample space for this trial. So one way to write your sample space is how we showed it before. The other way to do it is, do you guys remember like a tree diagram? I'm just going to show that first. So your first option when you flip that coin for the first time is heads or tails. Now picture it flipping again. After heads, you could get heads or tails. And then after tails, you could get heads or tails. That's your second flip. Now, if you flip it again, you could get heads or tails, heads or tails, heads or tails, heads or tails. So you could write it like that as a tree diagram, or you now can write out your sample space. So what's your sample space? Well, look down that whole left column. One possibility is heads, heads, heads. So you could have gotten 3 heads in a row. You also could have gotten heads, heads, tails, right? So heads, heads, tails. You also could have gotten heads, tails, heads. Okay? You also could have gotten heads, tails, tails. Okay? You also could have gotten tails, heads, heads. Tails, heads, tails. You could have gotten tails, tails, heads. And then tails, tails, tails. So 2 ways, either sample space, this is sample space, obviously, or tree diagram. Okay, either one would be acceptable. Now, how many outcomes are there? 8. So that's going to be your denominator when they start asking you probability questions. What's the probability that 3 heads are flipped? How many times did you get 3 heads? Once. So your probability is 1 out of 8. What is the probability that 1 head is flipped? So where is there 1 head? Well, either whether you're looking at the tree diagram, that first row, no. Here is 1 head. Here would be 1. So 1, 2, and 3. There are only 3 times out of 8 that you would only see 1 head. Okay? So like if I were to highlight, here's one with 1 heads, 1 heads, 1 heads. Okay? What is the probability at least 1 head is flipped? Okay, so that's a good one. At least 1. That means greater than or equal to 1. So that means it could be 1, it could be 2, or it could be 3. That means when is the only time that there's no heads flipped, and that's tails, tails, tails. So if at least all of them, at least one of them is heads, it would just be 7 out of 8 times at least 1 head is flipped. Because literally in all of them except for 1 head is flipped. And that would just be the tails, tails, tails that would not happen in. Okay. D, are these probabilities an example of theoretical or empirical? Empirical, definitely theoretical. This is theoretical. And it's because they are based on a sample space. Okay? They're based on a sample space. Okay, so let's take a look at the next one. And the next one, it says a survey is done by a marketing company, and they are determining which 3 pops were preferred by people in a blind taste test. So they give you all your information. Pop A, Pop B, Pop C, the number of people that preferred it, and the total. So what is the probability that someone preferred A, the probability that you would choose one person at random and find the following. Okay, so that's important. It's one person who participated in the survey is chosen at random. What's the probability that they preferred A? That's easy, 18 out of 53. Now, what's the probability of not A? Well, take literally 53 and take 18 away from it, that would be 35 out of 53 would be not A. Okay, because it would be, again, to get this answer, it's 1 minus 18 over 53. That's it. So it's pretty much 53 over 53 minus 18 over 53, which gives you that 35 over 53. Okay, they're called complements, A and not A, because not A plus A would give you back 1. Okay, what's the probability that you get an A or a B? Well, A or B, which would mean both. So you're going to add up A, 18, and 24, which would give you 42 out of 53. What's the probability that you chose one person at random and you get A and B? Never. That's never going to happen. You're either getting one person would either be A or B. Okay? So A and B is not going to happen, 0. Are the probabilities in this example theoretical or empirical? Definitely empirical. Okay? And this is because they are based on a survey. They are based on a survey. I'm going to say with actual data. Okay? Everything was based on this specific survey. Okay, I'm going to do one more with you. This one's kind of cool. They give you all the dice, right? And they tell you, roll a pair of fair dice. This is the sample space of the 36 outcome that are shown. Okay, so there's like 2 die, like there's your dice in each. 2 dice are rolled. Fair dice. Okay, so it says you record the sum for one roll of 2 dice. So this is important. You record the sum for one roll of both dice. Find the probabilities of, you get a sum of 12. Okay, so a sum of 12. The only pair, right? Do you see that? That would add up to 12 is right here. So I'm going to make that blue. Your probability of rolling a sum of 12 is 1 out of 36. Remember, it can't just be 1. It's got to be that 1 out of 36. That sum of the 6 and the 6 is the only way you're getting 12. Okay, how about a sum of 7? So let me pick a new highlight. I'm going to go yellow. And just like in that first row, here's your sum of 7, right? In the second row, 5 plus 2 is 7. In the third row, 4 plus 3 is 7. The next row, notice it's going in a diagonal. 4 plus 3 is that 7. 5 plus 2, 6 plus 1. So in that yellow, I hate to write in yellow, I shouldn't have highlighted in yellow, but whatever, your probability of getting a sum of 7 is 1, 2, 3, 4, 5, 6 out of 36. Now, you can simplify that if you want. In probabilities, you don't have to, but you could say 1 over 36. But I think I would leave it as 6 over 36. Now, here's a good one. What's the probability of it not 7? Not 7? Well, if the probability that it is 7 is 6 out of 36, just go the easier route. What's the probability that it's not 7? 30 out of 36. Okay, the complement. Okay, what's the probability that you roll a 7? I'm sorry, the sum is a 7 or the sum is a 6. So we know the probability that you roll a sum of 7, that was 6, right? There were 6 of them. How many of them have a sum of 5? Okay, so let's see. Where would be a sum of 5? Here's a sum of 5, 5, 5, 5. 1, 2, 3, 4. Is there another 5? I see 1, 2, 3, 4. Is that it? There should be one more. Can't be any here. Did I miss one? That's 6, that's 6, that's 4, 4. Or I swear there's another one. One, two, three, 4. All right, I know there's another one. It should be 5, but why am I not seeing it? So 6 plus 5 should be 11 out of 36. What's the probability of 7 and 6? 0. Okay, are the probabilities in this example theoretical or empirical? This is definitely theoretical. Right? This is based on a sample. You want to say, yeah, it's based on a sample space. I'm still trying to find the 5. There's got to be another one. The 5th. Oh, it's right here. Duh. There it is. I knew I wasn't crazy. 1, 2, 3, 4, 5. It was right underneath. Oh, that's why I first highlighted the ones that added up. All right, I got to fix this.